In this video, we are going to take a deep dive into Golang slice operations. We will explore slice manipulation, including appending, copying, and slicing. So, what exactly is a slice? A slice is a dynamic array-like data structure. Let's look at some code. We declare a variable named numbers, which is a slice of integers. Then we use the make function to initialize the slice with a length of 5 and a capacity of 10. This means the slice initially has 5 elements, but can hold up to 10 elements before it needs to be reallocated. You can also create slices using slice literals. Here, we create a slice called fruits, containing the strings apple, banana, and cherry. Slices can also be created from arrays. Here, we have an array called array of 5 integers. We can create a slice from this array using the slicing syntax. In this case, we are creating a slice from index 1 up to, but not including, index 4. So the slice will contain the elements 2, 3, and 4. Let's understand the internal structure of a slice. A slice consists of 3 main components: a pointer, a length, and a capacity. The pointer is a reference to the underlying array where the slice data is stored. The length represents the number of elements currently present in the slice. The capacity indicates the maximum number of elements the slice can hold before a new underlying array needs to be allocated. So, remember, the pointer references the underlying array. The length is the number of elements in the slice, and capacity is the maximum elements before reallocation. The append operation is used to add elements to a slice. Here is an example. Initially, we have a slice containing the numbers 1, 2, and 3. Using the append function, we can add the number 4 to the end of the slice. The slice now contains 1, 2, 3, and 4. We can append multiple elements at once by passing them as additional arguments to the append function. In this case, we append the numbers 5, 6, and 7, resulting in a slice containing 1, 2, 3, 4, 5, 6, and 7. To append all the elements of one slice to another, we use the spread operator, which is 3 dots after the slice name. In this example, we append the slice other to the slice, resulting in 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's look at memory reallocation. Slices automatically reallocate memory when their capacity is exceeded. Here is an example. We create a slice S with a length of 0 and a capacity of 2. The capacity is the amount of space reserved in memory for the slice to grow. Initially, the slice S has a capacity of 2. When we append the elements 1 and 2, the capacity remains at 2. However, when we try to append the element 3, the capacity is exceeded, triggering a reallocation. When the capacity is exceeded, a new array is allocated with double the capacity. The elements from the old array are copied to the new array. The old array becomes eligible for garbage collection. It's important to note that the capacity typically doubles when it's less than 1024. The copy operation is used to copy elements from one slice to another. First, you need to create a destination slice that is large enough to hold the elements being copied. Here, we create a destination slice, DST, with the same length as the source slice, SRC. Then, we use the copy function to copy elements from SRC to DST. The copy function returns the number of elements copied, which in this case is 5. You can also perform a partial copy by creating a destination slice with a smaller length than the source slice. In this example, we create a slice called partial with a length of 3, and then we copy from SRC to partial, which results in 1, 2, and 3. Slicing syntax provides a way to create new slices from existing slices or arrays. It allows you to extract a portion of a slice or array by specifying a start and end index. Here's how it works. We start with a slice S containing the numbers 0 through 5. To create a new slice containing elements from index 1 to 3, you use S 1 to 4. The result will be 1, 2, and 3. Note that the element at index 4 is not included. To create a slice from the start of the slice up to a specific index, you can omit the start index and just specify the end index. For example, S 3 which gives 0, 1, and 2. To create a slice from a specific index to the end of the slice, omit the end index and specify the start index. For example, S2I creates a slice containing elements from index 2 to the end, which will be 2, 3, 4, and 5. To create a full slice, use S parentheses, which means from beginning to end. The last one is a full slice expression. You can also specify a capacity. The syntax is S1 to 4, 5, which create a slice containing elements 1, 2, and 3 with capacity of 4. When working with slices, it's important to be aware of memory considerations. Slices share the underlying arrays. When creating a new slice from an existing slice, they both point to the same underlying array. Modifying the new slice may affect the original slice. To avoid memory leaks, be mindful of how slices share underlying arrays. If you only need a small portion of a large slice, consider copying the required elements into a new slice to avoid holding a reference to the entire underlying array. For example, if you create a small slice from a large slice using slicing, the small slice will still reference the entire large array, preventing it from being garbage collected. To avoid this, you should create a new slice with the desired size and copy the required elements into it. If you know the size of slice beforehand, pre-allocate memory using the make function.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.